Poynting theorem or Poynting vector is one of the important topics while you study your EM wave propagation. And while you study Poynting theorem, you must have come across with this term. We call this as the Ohmic power dissipated in the volume. And many students get confused with this term. Many students have asked me why this term is called Ohmic power. So in this video, let's throw away your confusion. Electromagnetic wave carries an electromagnetic power along with it. Yes or no? Electromagnetic energy or power. And we study that expression for EM power in the topic Poynting theorem or Poynting vector. Yes or no? And for deriving that Poynting theorem or Poynting expression, we start from the Maxwell's equations and we do analytical treatment, and finally we reach up to this expression. Yes or no? My dear, now I cannot include complete expression over here because that is not the title that what our video says. So this is the expression that we get while studying for the Poynting theorem or Poynting vector. And my dear, if you remember, from this expression you conclude that, yes or no, basically this is the Poynting theorem, and from this Poynting theorem we conclude that the power, the EM wave power, is given by surface integration of E cross H. Yes or no? But what our topic of discussion in this video is this term, this second term we call it as the Ohmic power dissipated in the volume. See, the first term, most of the students don't get confused with the first term. You know that in electrostatic you have seen that the electric energy density, that is epsilon E square, half of epsilon E square. In magnetostatic we have seen the magnetic energy density, half of mu H square. So the first term, the volume integration of half epsilon E square and half mu H square, it indicates the electromagnetic energy, and time derivative of that electromagnetic energy is nothing but the electromagnetic power. Am I right? So most of the students don't get confused with that first term, but many students get confused with this second term. Why this second term is called as Ohmic power? So my dear, I can explain you this concept by multiple ways, but I'm going to explain you why this is called as Ohmic power by very simple way, very simple way, by comparing it with your electrical knowledge. Okay, so let's see why it is called as Ohmic power. Volume integration of sigma E square. What is sigma? Conductivity. E, electric field intensity. So as I just said, you can prove this by multiple ways why this is called as Ohmic power, but I am going to tell you the very simple way. I am going to tell you what is the complete unit of this term, and I am going to compare it with your electrical knowledge. See, sigma E square, you can write it as sigma E into E. What is sigma into E? Conductivity into electric field. Remember what is sigma into E? It is J, the current density, conduction current density. Yes or no? We have seen in electrostatics, J is given as sigma into E. So sigma E square, it can be written as J into E. J, conduction current density, and E, that is electric field intensity. So what is the unit for J? Remember, what is the unit for J, current density? Ampere meter square. And what is unit for E? Volt per meter. So the combined unit of J into E or sigma E square, it will become current, ampere. into voltage divided by meter cube. Yes or no? So current into voltage divided by meter cube, and again it is under the volume integration. So dV, volume, its unit is meter cube. So meter cube will get cancelled. So the complete unit or this term is analogous to ampere current into voltage, ampere volt, current into voltage. And my dear, what do we call current into voltage? Remember your networks knowledge. What do we call ampere into volt, current into voltage? It is the electrical power dissipated in resistance. Yes or no? Current into voltage, in general terms of your networks, it is nothing but the power, watt. Yes or no? So my dear, this term is 100% analogous to power. Yes or no? Its complete unit is coming as ampere into voltage, current into voltage, that is analogous to your electric power, watt. And why this is called as ohmic power? Once again, very simple, because this term is indicating the power which is related to conductivity, conduction current, and the power which is related to conduction current, you know that in the networks, the power because of conduction current that dissipate in the resistive nature, that is nothing but the ohmic power. Yes or no? The power dissipated because of conduction current, conductivity, is nothing but analogous to ohmic power. So that's why this term must be analogous to power, and more specifically ohmic power. Very simple. So this term, my dear, the second term in your Poynting vector, many of students may write it in the first place, whatever, but what I am trying to convince you is that this term in your Poynting theorem is analogous to the ohmic power dissipated in your volume of interest. Okay, so very simple. In next week, let's meet with another mind-bending concept.